conversation. My name is Jiri Chaloupka. I'm also a technical marketing engineer covering the Evpn over IOS-XR portfolio. So I'm using the picture as an agenda. If you saw some of my presentations, you will say, oh, this is an old slide. Absolutely, it's an old slide. I want to show that basically we are really continuing with the investment into the services overlay as we claimed a couple of years ago. You can see that on the underlay, we have a different underlay across whole the network. We have an MPLS in the service provider network. We had like IP long time ago in the data center network. We have also options to go with SRv6, which is basically also IP network in the service provider as well as in the data center. But where basically right now we are going and where we have like really opportunity to really simplify the stuff is on the overlay. When you compare the data center and the service provider network, there was always a difference, right? If you remember the trail fabric path, in the data center, and for example VPLS for the L2 VPN services, but at the same time in the service provider, we always had the BGP control plane for L3 VPN services. When we go into the EVPN, we will get basically single control plane for everything across whole the network. Basically, and the single control plane is a BGP. Don't take it like EVPN is the control plane, BGP is the control plane. So basically EVPN is acting as a very important complement to all the BGP services. Basically with the L3 VPN, like a VPN v4, VPN v6 address family together with EVPN, we can basically cover any type of the service, basically really end to end. And it's actually very critical because when you will think about it, before the service providers, they didn't care about the data center at all. But right now, when we talk about the 5G and we are talking about more like the virtualization, in the end of the day, service providers are deploying much more something like a SPDC. And very important part here is the data center interconnect or border leaf. It always depends on the terminology. This device has to be like Swiss Army knife, basically like has to understand everything what is in the SP, has to understand everything what is in the data center. So that's a very critical part. When we will simplify, we can scale better, and we can definitely offer much better visibility on the end-to-end services. So let's really look at how we went over it. Really, I will not have a text, I will have just the pictures, and I will be showing how we will basically inserting into the network. So for us, with IOS-XR, especially with the ASR9K, the first logical step was to go on the DCI. We were solving a very difficult problem because we had to be like facing, as I mentioned, like we had to be facing the data center, but then we had to be also facing the service providers. And these two worlds, that time, were really different. So basically, it was really a challenge to basically be able to act as this basically like a gateway between these two worlds. So our initial deployment was basically for L3 VPN. So basically we had the traditional MPLS L3 VPN core, and we had L3 VPN VXLAN in the data center. That was the first step where we inserted like our IOS-XR in the network. The second logical step was like when the customers came and say, oh, we need to really extend the L2 over the core. We need you to integrate. First of all, you have to implement EVPN VXLAN L2 on your device, and you have to be able to integrate it with existing VPLS core in the network. It's actually quite a challenge because when you will think about it, VPLS is a single active network by technical definition, and VXLAN EVPN is all active. So there is a lot of tricks which has to happen, on the device to basically protect the loops and be able to do something like this. For us, another logical step was because we know, and you were also asking for us before, almost everything is a brownfield. So if you want to insert a new technology, you need to be able to do like a seamless migration, interop, and so on. So for us was like the very big challenge was like, hey, how we will go and we will insert into the existing VPLS core and how we will migrate this existing VPLS core into the EVPN to have really all active BGP-based control plane ready core. And so basically there was a very important feature where we can integrate the VPLS and EVPN in the same bridge domain, and we can do really step-by-step migration. That's just really important use case for the service providers. Then Another logical step, because when we implemented this L2 VPN in the core, was also go on the leaf side in the SPDC. So basically, we really implemented the EVPN L2 with distributed anycast gateway, because the beauty of EVPN is with the control plane that we can easily integrate L2 and L3 services together. So we can advertise MAC, but we can also advertise the host routes. And because of this, we can also synchronize our ARP. We can synchronize the neighbor discovery for IPv6. Later on, I will talk about IGP, so we can also synchronize the multicast state. So that was a very important step for us to move on the leaf layer. When we talk about like EVPN, always the natural start is the data center. So most of the time, when you look at like who started to deploy EVPN, who started with the EVPN in some part of the network, it's most of the time the data center, because of the all-active multi-homing, optimal forwarding, and so on. But when you will think about it, that you have actually same devices or you have same operating system. When we did this EVPN with the distributed anycast gateway, we used completely same feature set on our PEs. So basically, it's just a different size of the device. It's maybe slightly different ASIC because of the scale and so on. And we were able to go and we were able to introduce this technology on the PEs. What it means that I can go and I can remove, for example, my multi-chassis LACP. So I don't need any more ICCP channel between the two PEs. I'm using the EVPN BGP standard control plane to do this. I can also go and I can actually remove my first hop redundancy protocols like HSRP or VRRP, because when the EVPN is synchronizing my state, I don't need these two protocols anymore. So that's another way how we can look at the EVPN, how basically EVPN is helping to simplify the number of the protocols in the network. Another important step was that when you look at the service providers, right, first will be, we want to see the point-to-point services, right? I was always talking about EVPN like a multi-point, but in the end of the day, in service provider networks, most of the services are really like point-to-point. So we came and we introduced the EVPN Vpws service, which is again multi-home. We have all these different like load balancing modes. I will talk about it later on. And that's very important because it's also bringing like the high availability for the existing point-to-point services, because there is no any more need to have active backup pseudowire and so on. It's also very important to understand that EVPN with this, when I can do really all active multi-homing, I'm really simplifying the access, because when you will, for example, compare it with the HVPLS, again, like your access has to act as active, backup. You have to always be careful that basically what is coming into the VPLS will be basically single home or single flow active, because otherwise you will create the loop in the VPLS. That's basically VPLS technology limitation. As I mentioned before, another step was also like introducing the multicast. So we came same like we are able to synchronize the MAC address tables over the BGP VPN control plane. We are using the route type 7 and 8 for synchronizing IGMP join and IGMP leave to basically introduce the multicast into the EVPN. And let's look at the closer, because I started 2016, right? It's a long time ago. What actually happened in 2020? In 2020, we were able to go and basically across all the portfolio which we have with iOS XR, we were able to put together like all the load balancing modes. So basically, it doesn't matter if you will go with the NCS 5500 or you will have ASR 9K on the P roll. You can deploy EVPN ELAN or EVPN VPWS with all three major load balancing modes. It's all active, single active, or port active. Very often in the data center, you will go with the all active. We recommend most of the time to go with all active on the service provider side. We also see much more traction for all active than it used to be, but also the natural way with the service providers, because of the enforcing the QoS and basically enforcing certain bandwidth rules, they are going with the single active. So all these options are possible and basically are available on basically any platform which we are positioning today.
With the EVPN VPWS stuff, are you able to pass a lot of like frames and ether types that you might not be able to on a more traditional EVPN ELAN, more similar to what some vendors call like an E-pipe kind of thing?
Yeah, it's in the end of the day, like when you look at it, right? What's when we will compare it with the traditional pseudowire, doesn't matter if it's LDP signal or not, right? It's again a pipe, right? We have to look at it like the pipe. The beauty here is that first I'm able to do the multi-homing. That's the first important thing. Second thing is what I'm actually doing is that when I'm using the single active, I have to signal who is a primary, who is backup, because I cannot follow my MAC address. That's a very important parameter. I can signal MTU, so I have basically MTU check on the both sides. I'm signaling if I'm using the control word or not, right? So there is a couple of like a parameters, which is like basically in the EVPN signaling, but basically on the top of it, it's basically again like a pipe, right? So it's really important to look at, I want a transparent pipe. I'm again getting the transparent pipe from hardware programming point of view. I will get fully transparent service. That's very important.
Thank you.
Perfect. So another important use case is the EVPN E3. I call it here like, or we call it like based on the standard scenario 1. It's the use case where, especially for the service providers, imagine the BNG use case, where you don't want the basically like hosts which are connected to the access devices. They don't want them to talk to each other. You want to always go to the root, basically, where is a BNG, and basically there enforce all the rules, and then basically go back. So kind of like a hub and spoke. So basically, you want to always enforce the policy, or you want to have a statistics. Basically, hub and spoke topology. Here we call it when the host is connected to the leaf. So basically, leaf cannot talk to another leaf. They can talk only to the root. So we can imagine that the host is connected to the leaf. BNG would be connected to the root. Scenario number 1 is about having the bridge domain, which has only leaf or has only roots. So this basically we implemented. So this is like something what today you can go and you can basically like really enforce the certain policies on the particular leaves. Typical use case for the service providers. This we will not see too much in the data center environment. Very important thing when we will move on the BGP based services. Jose talked about like a different way how transport can be, like you can have like the flexible algorithm which will take you for shortest path or low latency path and so on. But right now the question is how basically the service will really integrate with this transport. And that's actually the beauty when you will have one control plane. This is something what we call on-demand next hop, where basically in the BGP, we are coloring the routes. So it means that basically we are putting the certain like the SLA type for the service. And just a matter of the type of the service, when it's L3 VPN, we are coloring the prefixes. When it's Evpn Vpws, we are covering the pipe cell, so it means route type 1. If it will be Evpn ELAN, we are also coloring the particular services. Theoretically, you can also color particular MAC addresses. And then when you will advertise it, you basically take it like, okay, I want to, for example, follow low latency path. Your egress P or ingress PE will basically go and will basically program the service into the transport, which is provisioned as for example, Jose mentioned before. So this is like very important integration, and then we can be completely transparent. It doesn't matter which type of the service you will have. If it will be EVPN, ELAN, EVPN Vpws, or it will be, for example, VPN v4, VPN v6. Another, when we will, again, I always like to talk about the brownfield, right? Because again, like brownfield is almost every time in the service provider network. If you remember our well-known design with the BGPLU for interdomain LSP, which we introduced with the UMMT design or seamless MPLS, later on also with EPN 5.0, where there was also segment routing. We also integrated this services, all the EVPN services with this type of the transport. So when you have a large network where you are using the BGPLU for interdomain LSP, you can again use the EVPN with any flavor on the top of this. And now let's look at what we actually did in the 2021, right? And this is for me like a very important part, because we were definitely challenged like by service providers and the customers. Hey, if I have today my existing like kind of like a flat-end network, it's a data plane, it will converge well, why I should go and I should care about the control plane. You are giving me all these scale reasons and so on. And here, basically, what we introduced, and actually right now we also like basically edit, we basically have a ITF draft for this one. I will refer later on in the slide deck. Is basically that we are able to provide the fast convergence even with the EVPN control plane. Everyone will think about, okay, if I learn something from the EVPN, I'm introducing it over the BGP. It will always take a time. That's the reality. So if you want to be really fast, you have to always pre-program the backup in the network. It's the same with the transport, it's the same with the services. You will probably recall the very well-known idea with the BGP PIC edge, where basically when you have a multi-home CE on your PEs, the PEs are basically backupping each other. We are going with the similar idea here with the Evpn L2. So basically, you can see on the slide on the left side, that, for example, the CPE1 between CPE1 and the one access device, I will lose the link. What will happen that moment? Of course, when I will want to signal on the remote side over the BGP, it will take a time. So a device will here pre-program the backup path into the second A, and then second A will basically send it back to the CPE. That's actually very, very important for any link node failure in the access, and we are then getting really sub-second convergence time or few milliseconds convergence time, depends on the particular deployment and how quickly I'm able to detect the link failure in the access. The important thing here that this principle is completely same again for a data center, SPDC, access, PE. It's basically when we deploy it, or we will develop this feature once, you can immediately use it across the whole network. And that's actually the beauty of using the single control plane for all the different type of the services. So with one feature, you are basically targeting whole your network today with this fast reroute.
Actually, BGP package we talked about now. So it is based on hierarchical FIP or generalized FIP, right? So if the device already supporting generalized or hierarchical FIP, so what you are doing here in 2021 for Evpn to basically come with the fast reroute. So what exactly you are doing for Evpn? Because if it's already supporting hierarchical FIP, so it should, any type of overlay, any type of service on top of it should be using this BGP capability for the fast reroute, right?
You're absolutely correct. You're absolutely correct. It's first of all, it's important to understand that you said it actually in the last sentence. It's a BGP, but think about it. Today, when I have Evpn, when I have L2, there is no any BGP between C and P. That's the first limitation. So I don't have this. So basically, I have to combine data plane learning with the control plane, and at the same time, think about like a basic rule which we have with the L2 in the core, with the VPLS with Evpn. To protect the loops, whatever I will receive from the core, I will never send back to the core. That's the first, this is a basic rule for any L2 core networks. So think about it, I brought this slide because I had it like later on. Think about this idea that I will receive from the core, I will receive the packet on the PE1. The PE1, right now the link is down, and the remote node, I didn't have a time for BGP to let know the remote node that this link is actually down. So PE1 will receive it. The P1 say, okay, I have a pre-programmed path, but my pre-programmed path is actually normally would be over BGP Evpn core because they are full meshed, right? But I receive this packet from Evpn. I cannot send it back because I would create the loop. So basically what we have extra bypass channel there to basically send it to PE2 to be sure that basically we will not create this loop. And it's very important that at this moment, PE2 will not do any lookup, but will basically really cross-connect to the access port. Otherwise, when the PE2 will have some logic, I can end up in the loop. And theoretically, with the PIC edge, there are also like the scenarios where we need to be careful. But it's important to remind that for IP, I have a TTL. I don't have a TTL here. So when I will create a loop, the loop will be there till the moment when I will kill the loop. That's very important. And most of the time, I will not kill my PE because PE is a hardware forwarding, but the CPE, which will be probably the software base, will be immediately dead. That's the important thing.
Maybe that link goes down and you are doing maybe next of self, so still the loop pack is up, so you are sending to PE1, it goes to PE2, and PE2 just send it to the attachment service.
Exactly. Again, it's also the reason why I'm comparing it with the BGP PIC, because we didn't want to, with the Evpn, we don't want to reinvent the wheel. I'm very often starting the Evpn presentation, I'm saying we took as much possible from the L3 VPN because there is a lot of things which is awesome. We just have to take care of the loop because of the L2. L2 is always more difficult. And it's also the reason why it makes sense to go on the overlay with the L2, Because every single time when you will want to troubleshoot the spanning tree or a G8032 or REP, whatever, you will have a native L2. You will never have an optimal forwarding, and you will have always a problem with the loops. Always. You will, sooner or later it will happen. Yeah. So this is a very, very important step, right? And I want to just remind here, when you look at it, this what we discussed is actually straightforward for all active. But then think for a single active, where you have to actually block one link. And this link, you have to be sure that the second router will not be sending any frames into the access, because the CE is actually doing data plane MAC learning. So you must be sure that only one device will be sending to the access. So there is a lot of like logic which has to happen, and you have to really follow strictly the rules. Otherwise, you can create a loop, or you will have MAC address flip-flopping. And again, MAC address flip-flopping with the hardware can be easy stuff, but with the software, you can kill it. If you
maybe
want
too much logic, what do you think? Maybe with VPLS, we were just having secret horizon. If I receive from pseudo wire, I will not send back to the core. So
absolutely, everything has a cost, right? If you will do single home service, it will be straightforward. You can do with the EVPN single home service, right? And immediately you don't have this type of the problems. If you want to have a high availability with the L2, there is a cost. And at the same time, when you have already the control plane in a place, the control plane is actually offering you this stuff to do for you. It's a matter of the hardware programming, right? So it's always like the balance, what you want to offer. And today, when we see like what's happening in the service provider networks, everything is about like high availability and faster route. Everyone is asking for this type of the protection and type of the services. I would really recommend, if you will have a time and if you will want to know more, look at this IETF draft, which is on the bottom of the page, because there we introduced, basically it was this October timeframe. We introduced this on the IETF during the IETF meeting, and we basically like opening this, and we want to have this like an open standard. So basically, it will be completely transparent for everyone. But with the FRR stuff, if you look at on the right side of the picture, we actually also introduce interesting way how to integrate the L2 legacy network. And we are actually getting more and more questions for this one, which is actually the proof that the EVPN is starting to be more and more mature type of the service in the network, because everyone has some legacy part of the network. So if you want to integrate it, if someone is asking integration old one, super old one with something super new, it means they are really deploying. For me, it's always a proof of the deployment.
I just want to restate something that you just said that I don't think ever gets said, but should be said every time. Everyone has some old/legacy part of the network. Full stop.
We would be lying to ourselves when we would try to claim that we have a new service which will not integrate with the old one. That's just the reality, and we have to live with it, right? So that's exactly why I'm actually proud of this part, that we are able to do it, and we are able to do it fast. So basically, we took all our FRR stuff which we deployed, on the previous nodes, and right now we are bringing it, with the legacy. So we are able to, when we will get a TCN or when we will get a MAC address on the different device, we are pre-programming some of the ARP entries on the backup node. We are pre-programming some of the stuff in the MAC address table to be sure that the convergence will be proper, and basically the customer will get a proper experience between EVPN and the legacy.
Thanks for covering the L2 legacy interop, because that's been, I spent a lot of time doing migrations of service providers, and that's a huge pain point for us. And a lot of it is due to the fact that a lot of the Metro Ethernet vendors that have traditionally been L2 only are just now getting into routing, and they may have LDP. A few of them are getting into segment routing, and a lot of them don't have EVPN yet. So the big challenge and gap we find is I can do VPLS on a Metro Ethernet vendor, and then I bring it into a more traditional core, with a vendor like Cisco. And how do I bring those two together? I mean, you have the stitching that you outlined, and then what we're talking about here about being able to do fast reroute and pre-program the ARP entries. I think that's great. And my question would be, since this is a draft in the IETF, what does the interop look like as far as testing? If I have a Metro Ethernet vendor that I like for the last mile and I wanted to bring it into a Cisco core, what does that look like?
Yeah. So right now, at this moment, like I don't expect the other vendors to have like the same level of the implementation because we just introduced, right? So
Sure, that's fair.
When you look at on the PE layer, these two PEs that must be Cisco, but access devices, anyone who do MST, anyone who is doing CREP, anyone who is doing GAT32 on the remote side, on the remote PEs, anyone who is doing EVPN. So basically, if you will want to right now tell me that I will have a vendor A, I have a vendor B, which is Cisco, and then I have another vendor in the access, the PE layer must be the Cisco, and then you can interrupt. There is everything else is completely transparent, right, from EVPN point of view. And on this one, I want to jump on one more, like my favorite use case, because I really like when we are using the EVPN control plane, not only for basic L2. I told about that, all this stuff like the synchronization of the ARP, synchronization of the neighbor discovery, right? And here, if you recall the use case where basically you want to bring from the access just the L2 pipe pseudowire into the PE, and then you have a head-end interface. Typically, it's L3, but it can be also L2, where you are basically enforcing your QoS, and you can do all the, for example, VLAN manipulation or PBRs on the IP and so on. This use case was very, very popular with the ASR 9K. But the problem is that we didn't have any control plane for a head-end, right? So it's always very difficult to provide any level of the redundancy right there. So right now what we did is say, okay, head-end actually, when we look at it from the interface point of view, it can be actually kind of like an access into the Evpn Vpws. So we are using the Evpn control plane on the top of the head-end, and we are driving the state. So when you look at on the left side, I have again my access, which is basically dual home from the CE point of view or CPE point of view, and I have my Evpn Vpws on my PE, and the P's are basically running redundant pseudowire head-end. And again, I can have all active mode, I can have single active mode. Typically, it will be single active because I want to enforce the QoS. But again, it's just another example how the control plane, standard control plane, can be used to basically drive the status of just another interface. This time, it's the virtual interface. But it's in the end of the day, just another interface. That's the beauty of this.
I saw on your last slide there, you replaced the VXLAN into the data center with MPLS. So as we're kind of moving forward, do you see, what do you see as happening within those data centers, right? Because now it's real Nexus centric, it's something like that, right? I'm not thinking about putting ASR 9Ks in a data center to go and deploy my services.
In the end of the day, EVPN is independent, right? So basically, from EVPN, purely from when we look at technology, I don't care if it's VXLAN, if it's MPLS LDP, MPLS SR, or there is SRv6. When it starts to be interesting is to think about like the integration, right? For example, if you will want to get a proper FRR, you will not get it like every time with the VXLAN. You will get it with the MPLS, with the TI-LFA, targeted LFA, or TI-LFA with the segment routing. If you will want to have a traffic engineering, you will not get it with the VXLAN, right? At the same time, we have a lot of VXLAN deployments. And as you mentioned, on the Nexus, there is a VXLAN, and as a Cisco, we are continuing with this one. What we see on the service provider side is the simplification on the both sides, right? When the service providers are running MPLS today, or they will be running SRv6 later on, why to run just another data plane in my SPDC? That's the more like the angle when we are going. Can I really have basically same device and maybe from the operation point of view, provision the service in the DC as well as in my access? Because what is the difference? Difference will be like the different physical topology, right? Which is completely hidden for me from the services point of view. So I think all these like the data planes will be there on the market. We definitely see with the service providers to going more with the direction right now with the SR-MPLS or later on with the SRv6. So basically like unifying like the SPDC as well as SP core and access. But as I also mentioned, we also started that basically we are able to integrate like the VXLAN data center with the MPLS core, right? So basically, I think that in the end of the day, we are trying to be flexible. Every customer has a little different requirements, but again, SP is the direction with the MPLS and with SRv6.